Well, here's an example to illustrate a couple of points. Well, what we got here is two methods in this interface, two in this interface, a couple of exceptions which both come from IOException, and here we come to this abstract class C, which implements the two of them. Right, now at this point there, we require that the return types of the P's be the same, because it's the same signature in each case on these P's. So if you try and implement two interfaces which are like this, where the method here has got the same signature, then you'll need to have the return type the same, or the two, or you'll get a compiler error because the two interfaces are incompatible. So you'll get an error at that point when it tries to implement both. Now, by the same return type, I actually mean that it's got the same erasure. So this can be slightly weaker than the same, but that's to do with generics. Right, now let's have a look at this abstract class. If you try something like that, M11, well, that method will be selected, and that one as well, both using method invocation conversion. And you can't distinguish between the two because neither is more specific than the other, so it's a compiler error. And the same thing happens again. In this case, again, you need method invocation conversion, and again it's a compiler error because it can't distinguish between the two. If we take a look at this though, it's fine, and it will select I2's method because these are both integers, so that will be selected by subtyping. Right, so that will come out first, and that one won't get a look in because it's won't be selected in. It was being selected by method invocation conversion, that occurs afterwards, so it's this one only will be taken, and that's it. Now if you look at that, it throws D, so that would be noted, and the reason I've commented that out is because I've got nothing in here, no throws clause or any try catch anywhere, so that's why I've had to comment that out. Right, now if we look at this second thing down here, P, get P12. Right, well that will select that by method invocation conversion, and that as well in the same phase. And they are override equivalent, so that's okay. And therefore what exceptions are common to both? And the answer is none, because they're both D and E are both subclasses of IOException. So there's none are common there, so there's no exception needs to be declared as being thrown there or caught. So that's the reason for that. This is a little flowchart I've knocked up to show overloading, and this is how you do it. First of all, you determine the class or interface you're going to have to search, and then you find all potentially applicable methods by examining the name and the number of arguments. And if you haven't found any, then it's an error. Next, you select from those potentially applicable methods, you select methods using subtyping, and if you found just one applicable method, then you've finished, that's done. If you found more than one, then you've got to sort them out down here, and if you found none at all, you go to the next phase. This next phase uses method invocation conversion on the potentially applicable methods. So you do boxing, unboxing and widening and that sort of thing. And if you found more than one, of course you sort them out. If you found only one, then you're home and dry. and otherwise you go to the next phase. And this phase only looks at variable arity methods, and you allow all the previous types of conversion, so that's method invocation conversion, plus you allow for a variable number of arguments, a variable arity type conversion. And if you found more than one, you sort them out on most specific. If you've found only one, then you're finished. If you haven't found any, though, that's a compiler error. So now you come to the most specific method you've got to find from those where you've selected more than one. And if you can't find a most specific method, then it's a compiler error. Otherwise you found the method. And you might not have the most specific if you've got two that are maximally specific and they're different, that sort of thing. Alright, just to illustrate a couple of points. Whether a call is ambiguous or not depends on the method invocation as well as the method being invoked. We got method M here, one that takes a string and one that takes an integer. And if you pass in null, it can't distinguish between them, because both are acceptable, so that's ambiguous, and you'll get a compiler error. If you cast it to string, however, that's quite okay. I'll select that one, of course. Right, overloading is done at compile time. It's sorted out at compile time. So the compiler, of course, only knows about the type of a variable. It doesn't know anything about what a particular variable might be referring to. The class of any object referred to, it doesn't know. It only knows the type. Okay. Well, this is just a little example to illustrate that the desired return type, if there was such a concept, plays no part in selecting the method. And here we've got a point, and coloured point is a subclass of it, with an extra field net, and two methods, both called test. One takes a coloured point and the other a point. One returns an int and the other returns a string. Down here we do this, create a new coloured point and call test with it. And that will generate a compiler error, because this call to test passing in coloured point will be satisfied. Both of those will satisfy it because they're both applicable by subtyping. So because they're both applicable, then the most specific one is chosen, and the most specific one is coloured. That one that takes coloured point, that one. So it returns an int. And so because we've got an int, we're trying to set a string to equal an int, you'll get a compiler error. The fact that you would desire to have a string rather than an int would be the ideal type. It doesn't play any part in it. Just to illustrate that it depends on the type of this parameter, not the actual thing pointed to. If we store that in a point instead, and call test with that p, a point, and of course it's that version which gets called, and that one is not applicable at all. It's not applicable because coloured point is a subclass of point, not the other way round, so you can't put a p into coloured point. And therefore that will work okay because you'll get a string out.